Today we're going to be working on example problem 2b5. For this problem we are asked to solve for the angular velocity of the rigid body OB through the use of instant centers. Given for this problem, we're told that the velocity of this block A is moving upwards with a velocity of 4 meters per second, and we are told that at this state we have an angle theta which is equal to 45 degrees. So in order to solve this through the means of instant centers, first we need to draw some sort of diagram that we can use to pinpoint the instant centers of what we know and what we don't know. What we're looking for is the angular velocity of the segment BO. In order to do that, we will have to relate it to the angular velocity of segment AB. In order to find the segment, the angular velocity of segment AB, we will have to find the instant center for AB. So first we'll have to look and see where point B is moving at this time. We know that the instant center of OB is point O, and that it is going to be moving in this direction. So our velocity is going this way. We draw a line perpendicular to that line of the velocity, and we'll get our instant center where it collides with the velocity of A. We know that A is moving moving straight up. So we draw a line perpendicular, and where those two lines intersect is our instant center for AB. So now that we have that out of the way, we can draw a set of diagrams to find the length of AB, which will be used momentarily. So to start, what we're going to do is find the angle phi. This will be used later on when we try to find the length of this segment between point A and the instant center. So we can find that by relating this, by drawing another line here and making two triangles that we can relate the two with. We can find the length of this segment by taking the sine of theta times the length of this arm. The length of this arm is 250 millimeters or 0.25 meters. We multiply it by the sine of that angle, which we know to be 45, and we get a length of B, which we then use, and we take the inverse sine of this length over this length to find our phi angle, which is 26.63 degrees. From there, we go down to our diagram, and we see that in order to find the angular velocity of segment AB, we will have to take the velocity of A and divide it by the length between A and the instant center. We can find the length of A and the instant center by adding up these two side lengths of this triangle. In order to do that, we know that this is a 45-45 triangle. This angle is 45 degrees, which means that this length here, angle length, must be 45 degrees. And this angle length must be 45 degrees, which will make our calculations a little bit simpler as we go along. We know that this length is 0.25 meters or 250 millimeters. We multiply that length by the sine of theta, and we find that the length of this segment and this segment is 1.77 meters. In order to find this segment, we know that we know the length of this segment to be 1.77 meters. We would simply multiply that by the tangent of phi, which we found earlier to be 26.23 degrees. And we find that this length here to be 0.087 meters. Add those two up, you now have this length and this length. Combined, you get this total length between point A and the instant center of AB, and you find that the total length is equal to 0.2638 meters. Okay, so what do we do with that? Well, we know that the velocity of A is going straight up, and its instant center is here. The distance, but we can find the angular velocity of AB by dividing it by the length of that arm. So we take our velocity of A, which we know is 4 meters per second, and we divide it by the length of that arm, and we find that the angular velocity of AB is equal to 15.16 radians per second. We can use this to find the speed here of point B by multiplying it by this length. We find this length by using the Pythagorean theorem. We have found this length and this length. We find the square root of the sum of the squares of those two lengths, and we find that the distance between point B and the instant center of AB is equal to this length here. From here, we have our, from here we multiply this length by the angular velocity of AB, and we get the velocity of B to be equal to 2.99 meters per second. We have one more step to go. We know that this speed now is equal to 2.99 meters per second. We know that this length of OB is equal to 400 millimeters or 0.4 meters. We divide the velocity at point B by the length of that arm, and we get our final answer to be equal to 0.747 radians per second counterclockwise.